Hi, everyone. Today I want to talk to you about division. We're going to be practicing division, long division, with two different strategies. The first one we'll try is the standard algorithm. For all you parents out there, that's exactly the way we learned how to divide when we were in school. I like to call that strategy Dead Monkeys Smell Bad. Now, it's a true statement, but it's also a funny way of remembering the steps in a long division problem. D is for divide, M is for multiply, S is for subtract, and B is for bring down. Those are the steps you follow when you're doing the standard algorithm. And once you get to the end, you just repeat that until you have run out of numbers. So let's give that a Let's try 6,479 divided by 31. So to begin with, I need to make 6,479 into equal groups of 31, but I have no idea how many that could be. It's a lot. When we use the standard algorithm, we just try to take a manageable piece of the problem and work with a little bit at a time. So I'm going to look at the first piece of this. So first I ask myself, can I take that 6 from the 6,000? Can I take that and divide that into groups of 31? Well, no, I can't. 6 isn't big enough. You need to find the first chunk that's bigger than 31. That chunk is 64. So I know that if I divide 64 into groups of 31, I'll have two groups. That's my divide step. Multiply the 2 times the 31, and that's 62. Subtract 64 minus 62 is 2, and bring down the next number, 7. Now I'm going to start the whole process again. I'm going to divide. I'm going to ask myself, how many groups can I divide 27? Can I make a group of 31? The answer is no. This is a really common mistake. Kids say, well, I can't make a group, so I'm just going to bring down another number. Well, you're partially correct, because what you're really doing is making 0 groups. So the thing that kids forget to do is put that 0 up top. So now I'm going to go ahead and bring down the next number. And now I'm going to ask myself, how many groups can I make of 31 from 279? Since I was really, really close, I could almost make a group, but not quite. I'm pretty sure it's a big number, like 8 or 9. And in fact, it's 9. So I divide 279 into 9 groups of 31. Then I multiply 9 times 31. That's 279. Subtract, that's 0. Bring down, nothing left. So that's my answer. I have 209 groups of 31 with 0 left over. So the next strategy I want to try is division with partial quotients. Kids like to call this the long 7 because it looks like a long 7 when you draw it out. So what we're going to do is be taking chunks or groups of this problem, 1,648 divided by 21. So the first thing I want to ask myself is, well, what's the biggest amount of 21 that I can take out? I always like to work with tens. So let's start with a friendly number, 21 times 10. Oh goodness, that's only 210. If I have to take out groups that small, it'll take me forever. Let's try 100. Oh man, 2,100, too big. Let's try something more in the middle. How about 21 times 70? Hey, that's a good chunk. That 21 times 70 is 1,470. That's pretty close to what I've got there. So I'm going to take out 70 groups of 21. Remember, division is making groups. So I'm going to subtract out the 1,470 that are in those 70 groups. And I'm going to get an answer of 178. That's all I have left. So now I want to take the 178 that I have left and put them in groups of 21. I wonder what would be a good choice. Let's try, it's definitely going to be smaller than 10, so let's try 8. 21 times 8 is 168. That's pretty close to everything I have left. So I'm going to subtract that out, and I only have 10 left. I took out first 70 groups of 21, and now I've taken out 8 groups of 21. So for a total, I've taken out 78 groups of 21. But what do I do with the 10 I have left? Sometimes kids want to add those in, but I'm not taking out 10 more groups of 21. Those are my leftovers. So I've taken out 78 groups of 21, and I have 10 left over. That is my remainder.